Hey there, Course 3, Lesson 9. We're going to be introduced to a couple of really important terms. First being prime numbers. Okay, prime numbers are ones that have exactly two factors. Exactly two factors, okay? Remember what a factor is. The numbers multiplied together that become that number. So what are the factors of 7? You might say there's none, right? 7, 7. There's nothing that multiplies to be 7. Well, every number has two factors besides 1. And that's 1 and itself. Prime. Numbers that only have 1 and itself as factors. They're a little bit rare. You can create a prime number chart using a hundreds chart that blacks out the ones that aren't. And we'll talk about what those are called in a moment. What's another number you can think of that has just its two factors? How about 11? Does anything multiplied together equal 11? Yes. Just 1 and 11 though. Once again, that makes it prime. Now what's the word we use for a number that has more than two factors? We call those composite numbers. So these are antonyms to each other. Composite means more than two factors. And that's a lot of numbers, right? Think of an example. How about 4? Small, not a lot of factors, but in addition to 1 in itself, it has the factor 2. I almost wrote it twice because you multiply 2 times itself. Just 3 factors, still composite. Let's try one more, 9. 9 includes 1, 9, and 3, which squared is going to be 9. Composite. What do I do with 1? 1 is a special number that is not prime because it has not more than two factors, exactly one factor, and that's itself. So not prime. You start your prime number list at, well, what's the lowest prime number? 2. Just 1 in itself. Another, 3. And so on. Prime factorization. Prime factorization is a process that's kind of fun. You build what's called a factor tree. To list the prime factors of a number. Pretty quick if it's a prime number, but it can be interesting if you pick, say, a composite number like 36, which can be broken up a couple of ways initially. What if we use a less traditional way, like 3 and 12? Did you know 3 and 12 equal 36? As we go along, we circle any numbers that are prime. 3 we said was prime. You could use a prime number chart to help you identify these. And then we continue to break down the other factors. 12 can, of course, be broken down by, let's say, 2 and 6. All right, do you see a prime number? 2. Keep going. 6 can be broken into 2 and 3. When we reach a point where no more factors can be broken down, we list them least to greatest. Either like that, or you can use exponents if you wish. Because this times this times this and times this will equal 36. You can show it as numbers multiplied to truly show they are prime factors, right? Now, divisibility tests are something that often people forget. Divisible means it's dividable. It can be divided by that number. Such as 2. You probably learned early on in your schooling that all even numbers are divisible by 2. So in the condition that the number is even, that means we can put 2 into it. You can know a number is even if it ends in 0, 2, 4, 6. So ends in one of the even counting numbers between 0 and 10. Such as 3,420, we know we can divide 2 into because it's an even number. What's the divisibility test for 3? How do we know if a number can be divided by 3? You can actually add the digits like in the number 3,420. You add its digits. You would never do this in any other case, but 3 plus 4 plus 2 plus 0 is 9. Then you ask if that sum is divisible by 3, which is much easier to tell than the number 3,420 mentally. The sum is 9. Is that divisible by 3? Yes. That means that the number 3,420 is divisible by 3. Make sense? If a number ends in 0 or 5, 0, it's not only divisible by 2, but it's also divisible by 5. Ends in 5, also divisible by 5. Have you ever noticed that all products of 5 end in 0 or 5? So the number 3,420 is divisible, according to these mental tests, by all 3 of these. Why is that useful? Because we don't even need a calculator to know it's divisible. You can combine these to use tests for other numbers, like if it's divisible by 2 and 5, then it must be divisible by 10 because 2 times 5 is 10. If it's divisible by 2 and 3, then we know it's also divisible by 6 because that's 2 times 3. Pretty cool, huh? Fun tricks people have figured out after enough time of using arithmetic, right? A number will be divisible by 9 if it's divisible by 3 because 3 times 3 is 9, the same factor twice. And finally, a number is divisible by 4 if its last 2 digits are divisible by 4. Thus, 3,420 is because 20 can be divided by 4, right? That number we know pretty quickly is going to be 5. So if the last 2 digits are divisible by 4, then the whole number is. Pretty cool. Are these prime or composite, and how do you know? We know this one's composite, meaning it can be divided by more numbers than just itself in 1 because it's an even number. Prime numbers are never even except for the number 2. How about 520,611? Let's try adding the digits. It's not even. It doesn't end in 0 or 5. But if you add 5 plus 2, skip 0, plus 6 plus 1 plus 1, let's see, 7, 13, that is 15. Is that divisible by 3? Yes, that sum is divisible by 3. That means this whole number that we added together to get 15 is also composite. It's divisible by 3. How do I know? Because it passes the divisibility test for 3. Pardon my dog. He must have seen something crossing the window. Maybe you don't hear it. I don't know. They use a squares arrangement thing you can learn more about in the lesson when it comes to composite and prime numbers. Feel free to check that out, but I'm just going to require, let's do A through E and stop there. A through E, please.